Bermudian triangle's about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
That was fun.
What's up, everybody? All right. What's up, P127? My dog. 99 cent. Let's get all these words in. Nice, nice. Hey, Lift, no. What's cracking? Good to see ya. Today's Tuesday.
That was fun. That was fun.
Wait, this is my wrong soundboard. Yeah, what? No, we gotta fix this. That was fun. Like, stop saying that's fun. This is the soundboard I want. There we go. That's my soundboard. That's the right file. Yeah. Well, let me clear all this. This is for my lecture. Well, actually, what I wanted to fix, just like before I start doing any questions today, during my lecture today, I was kind of reading out of a textbook for doing the electric field due to an infinite line of charge, and it was just wrong.
You done messed up, Aaron!
So I'm kind of upset at that. I'm gonna rewrite it right now, just because I want to be right. Okay, here we go. And then yes, I will do more questions from students. Let me just I want to fix this because this made me upset that this was wrong. Okay, cool. All right, so where's my pen? Aleph, that's a very worthy cause. Trying to derive the Maxwell distribution by yourself, like, that's pretty difficult. This one should be pretty straightforward. It's just the electric field due to a line of charge. Okay, so the general equation for like an electric field is equal to the integral of k dq over r squared. In, you know, I don't really like this, like this k hat. I'm gonna say this is just r hat. It always points back in the direction of r. And then what we end up saying is that if you have a charge density lambda, then dq is equal to lambda dx. Okay, so that's cool. So now I know E is going to be equal to, I can pull the k out. So that's k integral of lambda dx. We're going to go from negative L over 2 to L over 2. Doesn't really matter which direction you do it. What's up, Reiki? To L over 2. Over R squared R hat. And then the argument we make here is that the electric field from all my little DQ pieces here, all my little DQs, is going to keep just like pointing up, because the ones on this side will get canceled out by the ones on this side in terms of like the X direction. Yeah, that's what I say. I say, okay, well, the amount that this one electric field like goes to the left from this piece will cancel out the amount of to the left that, to the right, I guess, that this does from this piece. So I end up putting a cosine theta on there, I'm pretty sure. Okay, so then I say E, ooh, well, too thick. Damn, boy, she's thick. E is equal to K integral from negative L over 2 to L over 2. And then this is lambda cosine theta over r squared. And this is still dx, but now we're going to point this in the z hat direction. Okay, cool. All right, and then from this, if this is theta, then cosine of theta is equal to adjacent over hypotenuse. So that's z over r. So now I have E is equal to K integral of L over 2, negative L over 2 to L over 2. We can pull the lambda out at this point, I'm pretty sure. And we can pull the z out because z does not depend on dx. I think this is where the textbook fucked up. Because I think they leave a z in there. So this is K lambda z. And then I have, because cosine theta will pull a z. And then I have 1 over r cubed dx in the z hat direction. Yeah, you could do d theta. You could. But I don't want to do it from like one angle to one angle. I know that's what usually happens, Aleph, and it definitely does with, I think with Biot-Savart, right? That Biot-Savart law does that. If you've done that before, you do things with d theta. Okay, and then from this, right? Z squared plus x squared is equal to r squared. So z squared plus x squared to the 3/2 is equal to r to the 3rd. And that comes from Pythagorean theorem up here. Okay. So now I'm left with E. You did magnetism 6 weeks ago. Nice, dude. K lambda z integral negative L over 2 to L over 2. And then this should be dx, right? And then this should be z squared plus x squared to the 3/2. Okay, I think I see where I even messed up, like doing this integral. I assumed we were doing dz. Yeah, this was fucked up. Yeah, we're not doing dz. That's wrong. That's wrong. Yeah. Because it's dx, it's not dz, so this is not correct. Okay. This is actually okay up to here. They did this okay. I think it's the next step they messed up on. Let me see where that was. Big Monkey Man. I'm solving the electric field due to a line of charge. A distance z away. Oh. Also, my brain is much fresher right now because I took a nap. I really needed a nap. I was kind of struggling. Electric field, electric charges. Let's see where they're at here. You love this stuff. Cool, man. Yeah, yeah, E&M, right? E&M is pretty dope. So, this is how we did this. Okay, yeah, the question is going from this to this, which I think they were wrong with that. Let me delete this. Nope. I think they have like one too many Z's here. Yeah, dude, applying for jobs is brutal.
That's dope.
No. Yeah, yeah. What type of jobs are you applying for, Monkey Man? Also, the job market is just stupid difficult these days. You do have to apply to like literally 100 things, and most of these job postings on LinkedIn and stuff, they're fucking fake. They just put the postings up because they have to, but they're not actually hiring anyone. It's very annoying. Yeah, you can ask. You can totally ask in this stream. Yeah, this is whatever. I'm just starting it off by doing electrostatics because I want to do this for my own like peace of mind. I think there's a trig argument here. Yeah, I think because isn't this 1 plus tangent squared is secant squared? Or how's that work? Sorry, what's the trig identity? Yeah, 1 plus tangent squared is secant squared. Yeah, okay, so here's, I think, the argument you make. You say, I think you say, unless someone sees an easier way to integrate this dx, whenever I see x squared but I don't see an x up here, I'm pretty sure, and u sub's not going to work. So in that case, you have to say, like, x... let x equal, or sorry, let u or I want to pull, yeah, u equals, I want to pull a z out, is x over z, or no, is 1 over z, I think that's what I want to say. Yeah, 1 over z tangent of x. Then du is equal to 1 over z secant squared of x, right? Dx. Yeah. Yeah, the thing is, Monkey, you need to, like, go after jobs that aren't, like, part-time, no requirements, because everyone and their mother is trying to get those jobs right now, because everyone's fucking poor. Nobody has money. So, I was telling someone, actually, in my Discord about this, because they were frustrated. They're like, oh, in Canada, we have, like, a ton of Indian people here because they don't give a fuck about immigration or whatnot, and they're taking all the jobs, and I'm like, okay, well, maybe, but in my... You know, my little, like, rant about this is when people start, like, yelling at immigrants for taking jobs, like, immigrants usually take jobs that you don't want. Or they take low-paying jobs. Or they take jobs that they're willing to work for, like, shit pay. You don't want that. Instead of, like, blaming another group coming in who's just trying to, like, make a living, try to, like, make yourself better to jobs such that you can get jobs that they usually couldn't. Like, because I mean, by definition, you should have an advantage by not having had immigrated from another country here. And if you have immigrated, like, all props to you as well. But I told him, was like, you know, like, invest in some skills. Go to trade school. Go learn how to weld. Go be a fucking plumber or something. Like, go do something that is in demand. Don't, like, just go learn to code, because that's all getting replaced by AI right now. I know I told everyone you should learn how to code 2 years ago. I was wrong. I still think you should learn to code, because learning how to code teaches you other skills, which are very useful. But I was telling them, like, yeah, don't blame your problems on immigrants. Just, you know, blame yourself. Devil said, some tips. Oh, I got nothing. I'm 17. Well, okay, so I'll tell you what I was doing at 17. I worked in a biotech lab. And what I did was, because I knew how to code, it was called VBA at the time, so Visual Basic for applications, and they needed someone who could, like, do some stuff with their spreadsheets, and I took an internship, and I got paid $7 an hour, but it was cool, and it was a great resume builder, and I got to work in, like, a science lab. Yes, learn to code with systems and AI, that's also great. Yeah. Devil's asking some tips on learning chemistry. why do I have to learn the periodic table, and why do some rules only apply to 15 out of 233 cases? I'm going insane. Yeah, unfortunately, chemistry is the land of exceptions. The periodic table is not perfect. If you want to see, like, some wacky ideas they've had for the periodic table, let me see, like, alternative periodic tables. Oh, you're totally fine. I'm sure you will, Sid. I'm doing some electrostatics right now. But, bro, dude, they come up with some really wacky-ass, like, periodic tables. Like, this is apparently another periodic table someone came up with. Like, the spiral periodic table. Or, I've seen this one before, which kind of looks like a plumbus from Rick and Morty. If anyone's watched Rick and Morty. It's another wacky one. So, the periodic table is... It's like, it's an approximate. It's good enough. It has exceptions. And unfortunately, you have to just memorize those exceptions because they're not super logical where they come out of. Sorry, let me catch up more on the chat. There's a lot going on in chat. What's up, Recky? Sorry. Monkey Man, are you speaking through... Okay, here we go. Sorry. A lot of jobs need to be 18. Agreed. Yeah, because you need to be an adult. In that case, don't worry about like even trying to get a job right now because it's honestly probably fruitless. Because yeah, companies take a lot more risk hiring minors than they would with the pool of applicants that are already 18 and up, and they just don't got to worry about it. They would much rather just hire someone they don't got to worry about getting like sued for. When you go to college, you can get jobs. There are college jobs. College jobs are great. I worked many college jobs in college. So that can be anything from, you know, being a tutor at the tutoring center, or you can like go work at the library, or you can go work at a lab. That all works. I have some internship opportunities, but they said I can't take me on until I'm 18. Nice. Yeah, just wait till you're 18 then. You're fine. Just wait till you're 18. And yes, a lot of jobs won't take you because you're leaving for college in 2 months. Yeah. Because you're not... jobs will typically take people on because you're an investment. Think about it from the job perspective. They're going to invest like time, resources, and whatever, like getting you up to speed to do things at their company. And then you're just going to dip. They don't want that. Why are the prices so high? Inflation. Oh, for SCP points? Oh, I'll explain that later. College is expensive, yes. But don't worry, you can get a job at college. Recky, I'll explain it in a bit. Chill, don't spam my chat. Thank you, Shane. Thank you, Shane Tricks. Yeah, please stop spamming my... There's a lot going on in my chat. I can't keep up with everything, Recky, when you're just spamming it. Okay. Anyways, I feel for you, Monkey Man. Especially because it's the summer before college, right? You're probably trying to stack a little bit of cash before you head up to college to go do stuff. Yes. Okay. The age thing, that's just life, is what it is. You're 17. It's blame the lawyers. The lawyers made it difficult. I mean, also there are like child labor laws that protect children from like working, but this is also why I tell people, I know some kids are like, ooh, I'm skipping a grade, or like I'm whatever, I'm gonna blah blah blah. I'm like, don't. You can take whatever time, go learn more things, go, you know, pick up more minor degrees or whatnot, but when you start like skipping grades and doing stuff, you get into problems like this, where you're going to be at college, you'll be younger than everyone else, so you won't be able to do all the things that everybody else is doing, especially in the US when that comes into like, yeah, some things require you have to be 18, otherwise you need like a parent permission slip. And if you're some super genius that skipped like 2 years of high school, you're not going to be able to do anything until your sophomore year of college. It's just like, what? Just chill in high school. Don't skip the grades. You don't need to like rush life. You could go to community college at the same time and just get fucking credits for like whatever. Just keep racking up credits for things. To be honest, it was skip a grade or drop out. I was getting so bored I couldn't actually survive. Oh no. Ah! Yeah. Well, in that case, I don't know. I don't know when this happened. If it was in high school, you could have petitioned to just take harder classes. And then, you know, if your senior year, you'd already maxed out on all the high school classes, that's when you can go, at least for many people, they go to a community college nearby, and they go take, like, calculus, or they go take, I don't know, like, some upper div physics or chemistry class. Something that gets them credit for college, but you're still in high school, and you're still challenged. Because now you're in this problem of, like, you're not the same age as everyone else going into college, and they assume you are with all the opportunities and whatnot. And so it just starts creating, like, friction. That's like, I don't know, it's unnecessary. I get it. Kids are fucking brilliant. You want to go skip some grades. But, like, take it from me, man. You don't want to rush it. Don't. Your childhood is a very rare time that never will exist again. And so enjoy it while you have it. School is weird in my country. You got to sit classes with your grade. I was taking AP everything. Yeah. Again, everyone has, like, unique situations. So I understand. You did what you could. But yeah, in terms of the job thing, just wait till you turn 18. It's not worth the effort right now. Yeah. That's a legal problem. That's gonna be hard for you to get a job. Use this time instead to build up skills that could be used to get a job. So, for instance, go get some certifications. Yeah, if you want to be an EE, go. There are tons of, like, online certification stuff you can do for, like, I don't know, computer science stuff. In EE, you could, like, self-teach yourself. I don't know, like, circuits and mesh analysis. There's all sorts of wacky stuff out there. You're learning sign language. Nice. There you go. Good. Yeah, go learn a language. Just go learn a language or something if you're bored. That'll help you out too. Yeah, bro, if I forget, like, where you are and what country you're in, but if you know another language, that opens up a whole other opportunity of jobs to get. So for instance, if you're like a double E that also speaks Chinese, you're going to be very well sought after because they want you to talk with the silicon manufacturers overseas in, like, Taiwan or whatnot. So go learn another language if you want to. These are just things that, like, just boost your resume so that you get jobs easier. Anyways, I want to solve this. Let me solve this real quick. Sorry. I'm just mad. I'm mad that I couldn't get this during lecture. Also, I was running out of time. I only have an hour and 15 minutes to go through, like, all of fucking electric fields today. And I was like, that's so much. Okay. What's up, Amelia? I'm fixing this, Amelia. I'm upset that this is wrong. And I want it to be right. Maybe it makes some sense to you as we do it, too. K lambda z, right? Da da da. K lambda z dx. Oh, okay. So then I gotta, like, rearrange this. Okay. So dx is equal to z du over secant squared of x. Okay, cool. Great. I think this is a trig substitution. You have to do this, which, shout out to, like, Zach. He did 100 integrals today. It was his, he was celebrating his Twitch anniversary, or Twitch partner, or Twitch affiliate anniversary. I forget which one. So he did 100 integrals for, like, I think he did, like, a 12-hour stream. He was just, like, doing integrals, like, ridiculously difficult integrals. I should have given this to him. Be like, hey, man, can you do some trig stuff for me? Okay, so the dx gets replaced by z du secant squared x, and now this gets replaced with z squared oh no, sorry, I want x to equal 1 over z tangent of u. This is what I want to do. And then dx, sorry, I got this wrong. Bad. Okay, cool. Let me just take, like, I don't know, like 10 minutes to fix this. We don't need this. I screwed this up. I screwed all this up. Okay. 1 over z secant squared u du. And then this is all over z squared plus oh, I think I want this to be z tan u. Sorry. I'm like double fucking up today. I have to remember, like, trig sub. Okay. This is z secant squared. And this is z squared. Tangent squared. What's up, Sam? What part of Europe are you still in, Sam? Where are you at? Okay, then this is to the 3/2. Because I want to show that this eventually becomes... This is wrong. Yeah, I don't think what they get here is right. So let's check it. Germany, fly back today. Cool, man. Okay. So I can pull a z squared out of this. And then to the 3/2. That's z to the 3rd. So this becomes z to the 3rd 1 plus tangent squared u. Okay. I got a 75 on my math exam by my teacher. Dude, that's garbage, dude. What? No. So they just give you a grade and don't tell you like how you got your grade? I hate when teachers do that. Sorry, I should probably show how I did this. Yeah. I don't know how teachers get away with that, man. That's pretty ridiculous. Wait, can you see all your other grades on like why you got a 75 in the class? Or are you talking about just your final exam? Yeah, Amelia, dude, it's usually because your teacher doesn't want any like debates. They just want to be like, here you are, we're done, get out of here. Which is wrong. Especially when you put in like all that effort all quarter. Like what? Why? No quizzes or exams. I also don't like this because like how do you tell like what you did wrong, you know? Also, I'll be real up front. I mean, I make mistakes. Everyone makes mistakes. I made mistakes today in lecture, like deriving this. They probably made mistakes grading your exams, which I've definitely done that. I've definitely made mistakes, and you need the ability to call someone out on that. Yeah. Okay, well this is cool, because z cancels with this to make z squared. And this cancels with this to get you just secant of u. Okay. So then I have k lambda z integral from negative L over 2 to L over 2. Can I teach physics 1C next quarter? Trust me, everyone that I was teaching 5A in last quarter like begged me to teach 5B in the fall. I'm currently not hired for the fall. I'm going to go talk with someone tomorrow or Friday about that. But yeah, apparently UCLA is fucking broke or something and they can't hire me. So, I don't know. I'll go talk to them, see what's up. You didn't deserve them? What do you mean you didn't deserve the points, Monkey Man? Is it because you didn't show your work? If you don't show your work, like... Yeah, you're not going to get it for that. Okay. But then secant of u is just cosine. So this is k lambda z. Negative L over 2. L over 2. Oh, and this is going to get a 1 over z. Here, let me, like, put this in colors here. Someone's going to get mad at me that I didn't put the du. Okay. Cosine u du. Integral cosine's negative sine. Cool. So now I have k lambda z. Negative sine of u. But u... Oh, this is kind of cool. Actually, I see where this comes in. Negative sine of u. From negative L over 2 to L over 2. I hope you get fired. I appreciate that. Thank you. That's a generational fumble for UCLA. Yeah, we'll see. I get the impression that they don't really care about the quality of the teachers. It's just money. At the end of the day, they're just like, we either have the money or we don't. And as long as you're not being like an egregiously terrible teacher, I don't think you necessarily get rewarded for being a great teacher. Which I think is probably why most teachers just don't give a fuck. They just kind of do whatever like is acceptable enough not to get fired, which is wrong. Is our universe inside a black hole? Yes or no? Wow, she claims she expected... Dude, this teacher cares a lot about you, big monkey man. She claimed she expected more from you. Wow. Well, okay. I will say, when I give partial credit, I will go back through and check who it was. And if that's someone that, for instance, came to office hours a lot or really put in the effort, like really asked me questions, like was always like present, I am more forgiving, for sure. Because I know they're legitimately trying and stuff. Okay, yeah. We're almost there. Okay. But x over z is equal to tan u. This is kind of cool. So watch this. X over z is equal to the tangent of u. So now you build like a triangle. This is kind of crazy, right? You're not going to have to solve an integral like this on the calculator. No. No, I would not do this to you, Sib. This is terrible. All right, if this is angle u, right? So opposite over adjacent, so it's x over z. So then this is the square root of z squared plus x squared. This is actually really cool how this works. Okay. So sine of u is equal to opposite over hypotenuse. So that's equal to x over the square root of z squared plus x squared. Bum, 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 bum. Actually, sorry, the integral of cosine is not negative sine, it's just regular sine. Okay, let's see. I think we're getting closer. We're getting so close. So now I have k lambda over z, which is what they have here. This is k lambda. They have k lambda z. Bro, this is... Oh my god, this is so wrong. What is going on here? And then it's x over the square root of... Sorry about that. Let me show it to you guys. Sorry. Z squared plus x squared. Z squared plus x squared. So sorry, I think I had my screen off when I was showing this. Okay. X is z tan u. X over z is tan u. You can make a triangle. Tangent of u is opposite over adjacent. So opposite over adjacent, x over z. And then by the Pythagorean theorem, you can figure out the hypotenuse of this like new triangle. So the sine of this angle u is then the opposite over the hypotenuse, which is then this. And then we're doing this from negative L over 2 to L over 2. Which, let's compare. Let's compare with what Kudu had. This is already just K, whatever. So they have like Z instead of Z squared over Z squared. So that's wrong. It should be just a single Z. Let me go fix that. That is wrong. Okay. I was running this. I was like, yo, dog. Too many Z's. Can physicists get a job? That's an interesting question, Aleph. No. I mean, I'm a physicist. I have a job for now. Actually, you know, if you want to go outside of physics, you can definitely get a job. They hire a lot of physics people to do like finance and like modeling and stuff. Mainly because like physics teaches you a way of thinking, which is really cool. It's just like a way to like solve problems that you don't necessarily know the answer to. You learn how to take other toolboxes and like systems and put it towards a problem. It's problem solving. It's very cool. Oh, you want to do physics research? Yeah, you can. You just won't get paid a lot. Yeah, just expect to be working poverty wages. But yeah, you totally can. Okay, let's see where they fucked up here. Okay. So 1/4 pi epsilon non frac lambda L. Wait, what is going on here? Okay, there is no extra Z out here. That's what they screwed up. Well, actually, let me take the Z out of the front. Let me take it out of here. Yeah, let's take that out. Okay, let's see if this matches now. Is that what I want? Yeah. K lambda great. What's up, Marty? Okay, awesome. That's fixed. Okay, and then the question is, when I take L over 2... Monkey says, wait, I just realized that I know you've mentioned multiple times that you're a physics professor. I'm technically a physics like lecturer. Professors is like a whole other term. I do teach physics at a big college, so I kind of professor, sure. Could you explain what office hours are and any other advice for STEM stuff? Yes, I will go through homework stuff. Give me a second. Yeah, so, I mean, this isn't a good example of office hours because I'm not really answering someone's question. I'm kind of answering the class's question. But office hours is a great time for you to just show up and ask questions that maybe couldn't be answered, like, during class because it would take too much time, or to, like, clarify something. One sec. I think I got this. And that's what I try to mimic here with what this is. I try to mimic what office hours are. And I say, like, come to office hours, talk to your professor. Clear it, because things can't make sense during lecture sometimes. There's just not enough time. Right? And so this is the way to, like, fix that. And also then you get FaceTime with your professor. Your professor knows who you are, which is useful. Is this wave geometry? No, prototype. This is solving the electric field from a line of charge. It's this integral that is just an absolute brutish mess. But I think we're done here. I think we're done. And then I'll move on. Okay, so this is K, lambda. L over 2 minus L over 2 is just L. So you get K lambda L all over, and then this is Z. And then this should be the square root of z squared plus L squared over 4. Yeah, which I think they messed up because this is what they got. And I don't think this is the equation. This is what they had. So the 1 over 4 pi epsilon naught, that's the k, lambda L, and then I got a single z. They had an extra z down here somehow. Let me make sure I didn't mess up. I don't think I did. It's usually scheduled. So here, if you want to see like an example of like, oh, sorry, that's wrong. One second. Oh, sorry, I gotta log into. I do because otherwise it looks like a 2. L is just the length. That's all it is. Yeah. Z through is like technically like zeta, I think, or whatnot. But anyways, here, I'll show you, like, for example, this is what, well, here, this is my 1B class. But this is like, you get a syllabus, and usually the teacher will say, like, hey, office hours, and then, like, what day and time. Here, everything's online. But if it's at a college, they'll usually say their office. It's like literally an hour in my office for you to ask whatever. And it's a way for you to get almost like free tutoring, which is great. But like one-on-one time, or it's a couple people. Like sometimes my office was filled with like 20 or 30 people, especially like right before exams. And it's an opportunity for you to explain something slower and more, completely to a smaller audience. What type of physics do I teach? Just intro physics. Yeah, this is intro UNM. Okay. I think this answer is correct. I think this answer is wrong. I can like kind of Google this. Let's see, like equation for electric field of line charge density. Someone has done this, guarantee you. I don't want it for. I want it for a finite length. Yeah, here we go. Yeah, you're right, Aleph. They do it with theta. No, actually, they do it with L over 2. Yeah, bingo. Look at this. That's the correct answer. This answer is wrong. Ha ha ha. Okay, I'm gonna fix this. And then I will go do all the other questions, sorry. Where was it? 1 over 4 pi epsilon naught. And a fraction, lambda L. Oh, man, where was this in it? Okay, cool. All right, sorry, thank you for waiting as we did that, this whole derivation. Yeah. Okay, cool. Wow. This is wrong, this is wrong, this is wrong, this is wrong, this is not right. We did it. Love. Just took 43 minutes for me to go through that whole thing. Unfortunately, yeah, their line charge is probably going to be wrong too. Well, Let's just hope it's not wrong. I'm not gonna deal with it. Yeah. Okay. We did it. Sorry. Have I published research? I have published research. If you want to go look up my research, you can. I think you go to like Google Scholar. Giovanni Rossi is my name. Plasma. There you go. There you go. There's my research. If you want to go see what I published. I don't publish anymore. Madi, but because I mainly teach right now. But there's stuff if you want to go. Yes, we'll go over it. All right. Sorry. Yeah, let me go over everyone's questions. Let me catch them on chat real quick. Monkey says, how do I bully my college into letting me live on campus? Because rent is why can't you live on campus? They usually do offer on-campus housing, especially if you're a freshman. Especially if you're a freshman. Okay. One sec. Got that. Two lambda over z. Cool. Oh, there's no L. And let me save this, because I'm going to upload this as the lecture notes. What was this? This was 1B 07-08-25. I'm going to say like revised. Cool. Yeah, totally, Amelia. You can totally ask about this. Let me go through what I got on. We got a lot of screenshots that got in so far. Let me see. Mistral. You have the first one. This is the resonant one, I think, Amelia. So this will probably help you out as well. Yeah? Here, let me delete all this. Or actually, I'll leave this page open. Okay. So let's see. Mistral asks this. Says, okay, a tube driven by speaker displays resonances at 450, 600 hertz, and no resonances in between. The fundamental frequency was found to be 150. What are the boundary conditions on the tube? Cool. So that has to do with what the resonance are as like what type of multiples they are. And yeah, it's the I get it. This is the sound and music stuff. Let me find a diagram of this. Sorry. Open standing wave. Maybe this has them. Yeah, this probably has them. There's like one diagram that's like super good at showing all of them. This is a good one. Yeah, okay, here. Let's take this one. Let's take this image. This is a good one. And then there's probably this one. Good. Yeah. I think it's open, actually, Aleph, and I'll show you why. And then, do they have like a closed one? I kind of want a closed one. These are all open. Where's closed? Okay, here we go. This is another one. But that's the... I want the frequencies. Here, one sec. I'm going to say closed. They are the same pattern, but the waves look different. It's the same in terms of the frequency. You're correct about that, but how the wavelengths form are different. Okay, I think this is what I want to show this. Okay, here we go. Fine. This is good as well. Just trying to like save time with me like drawing pictures all day. Oh, wow, that's very big. Okay, we can make you a little bit smaller. Okay, here we go. Okay. So it says the fundamental frequency was found to be 150 hertz, okay? So that means that, like, F1 is equal to 150, okay? And then we have, like, let's say, like, Fn and Fn plus 1, because we say there's no resonance in between, right? So these are what we call, like, consecutive. Like, they're coming one after the other, right? So that's going to be equal to 450. And then that's going to be equal to 600. Okay. Well, this difference here, 150, is the same thing as the fundamental, okay? So, for instance, this can't be it can't be like the odd frequencies, the odd multiples. Let me show what I mean by that, sorry. Okay. In the case of having something that is open-closed, okay? So this is open on this side, closed on this side. The lowest frequency or largest wavelength that you can fit, the largest wavelength of wave you can fit is where the wavelength is 4 times the length. Or more so that only a quarter of a full wavelength fits inside of the cavity here. And that's because this side is fixed. So this is a node, and this is open, so this has to meet at the boundaries. You have a quarter of a wavelength. That is the distance L. And if a quarter of a wavelength is L, that means a full wavelength is now 4L. And then if you want to solve for the frequency, because let's remember that V is equal to F lambda, that means that the frequency is equal to V over 4L. Okay? So this is the wavelength and frequency for the fundamental. All right. If we try to fit more of the wave inside, okay? So here we only tried to fit a quarter of the wave in, and that worked. The next thing I can do is to fit 3/4 of the wave in, because now I can have it do this. Again, it has to have a node here and an anti-node here, or like a max. And when that happens, now I have 3/4 of a lambda fitting inside L. So if I rearrange for lambda, I get lambda is 4/3 L. And if you do this, V equals F lambda, you can then solve for F. And you get that F is equal to 3/4 V over L. Notice a relationship here. F2, so the next harmonic, is equal to 3 times the first one. This is equal to 3F1. And then you can go again and be like, okay, how can we fit more? Okay, well, I already did that. So the next thing would be to do this. And in this case, now I'm fitting 5/4 of a lambda in there, right? So I have a full lambda and then another quarter. So this now becomes F3. So lambda is 4/5 L. V over lambda then gets you 5/4 V over L. And so now you have 5 times the initial frequency. Because remember that this part is F1. Or here, can I make this like a little smaller? Sorry, let me make this smaller. Yeah, so this, and then this part right here. Right. Can I draw? There you go. This is equal to F1. And then you would have 5 times F1. Okay. It's because the pressure antinode with the closed end and the displacement antinode when open. Yeah. Well, with the closed end. Yes. Well, that's when it's open. So yeah, in the case of something being open, okay? Now you need antinode. And so the least amount of wave you can fit in there is when you have half a wavelength, right? So you have like one thing here, and then you're missing the other half of the wave. So in this case, half a wavelength is L. So a wavelength is equal to 2L. Right? So if 1/2 of a wavelength is equal to L, then if you just multiply the 2 over, right? Lambda is equal to 2L. And then the next case you could do is like, cool, I could have it open and then open here. And now I'm fitting in 3/2 of a wavelength. And so now if I solve, right? Wait, is this right? This is probably not right. Wait, what? Excuse me? Oh, wait, no, this is a whole wavelength. Sorry, what am I talking about? Sorry, it's not 3/2. Sorry, this is half a wavelength. This is a full wavelength, right? Because it's peak to peak. So lambda is just equal to L. This is where it's 3/2. Yeah. Because this right here is 1 wavelength. And then this to this is another half a wavelength. Yeah. So in these cases... Sorry, the case I'm talking about is the stopped pipe where it is over 4L. The stopped pipe. Stopped? What stopped? You mean closed pipe? Anyways, the main thing here is that any of your harmonics are now 3 times, 5 times, 7 times, and so forth, right? If we look at this, right, this is how much of the fundamental frequency. Well, I say, okay, cool, this is 3F1. This, 600. 600 is equal to 4F1. And this makes sense because they should be like the next harmonic, right? But since it's 3 times and then 4 times, the only way you can get 3 then 4 is with either open or closed. So here, right, F1 is V over 2L, so then F2 is equal to 2F1, F3 is equal to 3F1, F4 is equal to 4F1. You can have every, like, N going up. It's the same thing here. So this is F1, and then this is like 2 times F1. So here F2 equals 2F1, and then this is F3 equals 3F1. So because the multiples is going 3 then 4, this tells you that it can't be open closed, because open closed would have to be 3 and then 5. So here, this is kind of like a little bit here. So like, if it was open closed, then you would have 450 is equal to 3f1, and then you would have 750, which is equal to 5f1. This would be like the next harmonic. Does that make sense, Mistral? And Amelia? Does that make a little bit more sense with the resonances? The number one thing I can like tell you guys is try to like really study these and understand where they come from. The three cases. So open closed, open open, and closed closed. If you understand like how the wavelengths fit and the patterns, that'll help you out a lot. What's up? Monkey Man asks me, ooh, what is this? What are your thoughts on AI from the perspective of a college lecture? I think AI is a great tool, but it's a terrible crutch. I've said this a couple times, but yeah, in my eyes, like AI makes things a lot easier to do, which is great, but you don't want to make everything too easy because then you don't really learn anything. So, I mean, I use AI all the time to like double check my work. But you don't want to be using AI to just do things that you should be learning. You studied since even before the class started? That's crazy. Wow. I mean, you could have. Yeah, right, Sid? Because there's so much stuff online. Like, all the stuff already exists. And that's smart for you to do that because this class is fast. It's very fast. Oh, could I redefine resonance for you? Sure. Redefine resonance. Okay. So, yeah. Resonance is, well... there's a lot of different things for resonance. So we can talk about like the natural resonant frequency of like a rope. That's kind of like the fundamental. Well, that also depends on the tension and stuff. If we're talking about like harmonics are just higher frequencies of the waves that fit in the same geometry. It's like everything has like a fundamental frequency. This is the base frequency. You could say it's the base resonance that happens. But then all these other frequencies happen as well. If we're talking about like standing waves, the reason standing waves occur is because you have a certain like propagation of waves inside a boundary such that it's favorable for things to like constructively and destructively interfere well. So there was something we did one of these in, what was it? Let me find it. It's on YouTube. It's like Zach's physics, I think is what he does. Zach's physics. It's like traveling waves. I think this was it. Was this the animation? Oh, I don't need his music. Okay, anyways. Yeah, that's when waves like, okay. Yeah. So here's what happens. When you have two waves collide with each other, and the rate at which they're hitting each other matches some nice pattern, you get a standing wave. And this is resonance, is what it is. Resonance is when, like, the peaks are matching with the peaks, so you get positive interference, and, like, the zeros hit the zeros, and that's where you get the nodes. And it really comes down to, like, if you have, like, two waves coming at each other, how they interact, like, through each other. Exactly. Yeah. Yeah, two waves kind of, like, collide and, like... Resonance is definitely a standing wave. Resonance is 100% a standing wave. Yeah. That's what we talk about when we talk about resonance. But it's when, like, two waves are, like, hitting each other, but they're coming at each other at a certain rate that causes it to look like it's not really moving at all. Yeah. Night, Monkey Man. Hope you have good luck with all the college stuff. Always come by. I'm happy to give my advice, opinions. I talk a lot. We could ask ChatGPT what it thinks the definition of resonance is. I would just like to ask it, you know. What does it think? How would you define resonance in terms of physics? I don't know. Just curious. See what it comes up with. They say resonance is a phenomenon whereby a system oscillates with maximum amplitude driven by a periodic force whose frequency matches one of the system's natural frequencies. Yeah, cool. It's kind of what we're talking about. Standing waves are an example of resonance. It's where you have a lot of positive interference. Yes, the army marching, destroying bridges, that's also resonance. Agreed. Yeah, that's another resonance condition. It's like the frequency things want to oscillate at. So when we did the pendulum, like a simple pendulum has like a fundamental frequency that it wants to oscillate at, and that's a resonant frequency. If you start applying like a driving force or you have damping, then there's also a frequency that things like to resonate at. It's like what's most natural for it. And then we'll get into this. In circuits, you can have resonance. And then acoustic resonance is what I think we were just going over. And that's air columns, which, yes, they resonate at frequencies determined by their length and their boundary conditions. Right. And these are the standing waves that we talk about. Frequency things want to oscillate to achieve, yes, maximum amplitude. Yeah. Yeah. Okay, let me do this one. Let me do Sib's question, and then I'll take a look at the LRC circuit one. Yeah, that's probably a fun one. All right, let's see, Sib. All right, say two audio speakers are placed on a vertical rail. Speaker A is placed at head level, while speaker B is placed at some variable height, delta Y, above speaker A. Both speakers receive simultaneous inputs from a sine wave generator. Okay, with a wavelength that. Calculate the lowest height B can be placed above A to produce a minimum sound of a person heard. Oh man, this is a geometry question. Okay. So we have speaker A at head level. Oh, and we're going to assume that that's the height of the person. Let's just say this is H, right? And then we have a person. And they're a distance, let's get this right. They're 3.55 meters away. And then, oh, and speaker B is above speaker A. Oh, that's cool. So one sec. This is speaker A, right? And then speaker B is placed up here, some variable height, delta Y. And we want to know, and then we say that lambda is equal to 0.885 meters. And then how low can B be placed above A to produce a minimum sound heard by a person standing 3.55 meters away. Okay, cool. So you have like two different paths, right? So speaker A is going to have some length here. Let's call that A. And then speaker B will have some path length B here. And in order for there to be minimum sound heard, right? So for minimum sound, you need the path difference. This is a double slit experiment. It literally is. It's kind of cool, actually. Yeah. This is a double slit question, really, yeah. So you need the path difference between these two. You need B minus A to equal half a wavelength. Right? Because if if this wavelength difference is off by a half, then you have... Or here, let me do 2 different colors. Yeah, let me do this as like A. And then let's do this as like B. Right. So if B is off, you see how this is like B minus A is equal to 1/2 of a wavelength? Then the peak from A will match the trough of B, and these will cancel each other out. So that's what we're trying to do. We're trying to figure out B minus A is equal to half a wavelength. Okay. Well, I think this is just like the Pythagorean theorem, right? Because B is equal to A squared plus Y squared. And I want B minus A. So I want this. So oh, and we already know what A is. A is 3.55. Okay. So B minus A is going to equal to A squared plus Y squared minus A. Nice. We want this to equal to 1/2 lambda. Right? So we're solving for Y. I know what A is. A is 3.55, right? So 3.55 squared minus 3.55 whatever plus Y squared is equal to 0.885 over 2. Where's my calculator? Where doth go my calculator? My B is wrong, he says. What's wrong with my B? Oh, B squared. Thank you. I made a mistake. Sorry. Yes. This is B squared is equal to A squared plus Y squared. So B minus A is the square root of A squared minus Y. Okay, thank you. Yes, okay, I gotta fix that. Sorry. Yeah. I think you could probably do this with like the small angle approximation, but why do we want it to equal half of... so here, Mistral. So let's consider the wave from A being this red curve here, and the wave from B being the blue curve, okay? So if they traveled the same distance, okay, then they would have constructive interference at whatever, like, the endpoint is, right? Because they would both be peaks, or they would both be troughs whenever they hit here. If, however, I make B travel further, okay? Let's say I make B travel half a wavelength further, right? Because from here to here is half a wavelength. Then wherever B is, because A got like basically a head start, like B got a late start, right? B has to travel from further away. Wherever these meet, now B will always be completely out of phase with A. And that creates a minimum. That's destructive interference. So I said, okay, well, the length that the sound wave has to travel on B, subtracted from the length it has to travel on A, has to be half a wavelength. And then from the Pythagorean theorem, I know that A squared plus Y squared is equal to B squared. So then B minus A is going to be the square root, right? Because B is equal to the square root of A squared plus Y squared. Minus A is equal to 1/2 lambda. And now we solve for A. So this is 1/2 lambda plus A. We're going to square that. That's going to equal to A squared plus Y squared. So then Y squared is equal to 1/2 lambda plus A. We also have to assume they started at the same time at the same angle. And we do. Because we say that both speakers receive simultaneous input from a sine wave generator. Yeah. It's a good point, though. Minus A squared. Okay, so then I'm just going to like square root this whole thing. All right, let's just get some numbers real quick. Calculator. So it could be, yeah, no. So you're totally right. So it could be, this is the lowest distance. I could also have b minus a equal to 3/2 lambda, or 5. That's a good question, right? So I could have it, for instance, go back 3/2 of lambda, right? So this is it when it's half a lambda away. I could then also have it go like 3/2 of a lambda. That would also do it. But the question asked for what is the lowest height, right? So the lowest height is when we just have a single half lambda difference. Sorry, what is lambda? It's 0.885. Okay. So 0.885 divided by 2 plus 3.55. Square that. Minus 3.55 squared equals that. Square root everything. And you get that y is equal to 1.83. Okay, so y equals 1.83 meters. I think that's what it is. We could check this too. I always like to see like which questions ChatGPT gets wrong, because then it's kind of like a good indicator. He says it's too big. Oh, maybe. I don't know. I mean, it's a pretty big wavelength. Yeah. ChatGPT says 1.83 meters.
My man.
Yeah, I know it seems big, but it's because the wavelength's already big. The wavelength is, 0.885. Yeah. Also, you're not that far away, right? You're only 3.55 meters away. Or you are log... I forget, like, whatever. Yeah, 1.83. Nice. Okay, cool. Does that make sense, Mistral? Yes, kind of similar. Yes, exactly. Yeah, the path difference question you asked yesterday, very, very similar. Yeah, very important for you to like kind of understand how like path difference plays an effect with interference patterns. I'm sleep deprived. It's okay, Aleph. What time is it over there? Like 5 o'clock in the morning for you? Did you submit a screenshot, Aleph? Sorry, was it this one you submitted? And then also I see Winnie put something in. And then which one are you asking for? 18? Searching in the fog? Oh, is this fucking... This is not kinematics. Or is it kinematics? Or is it the speed of light stuff? Okay, one second. Let me see. Is this actual kinematics? Or is this special relativity kinematics? Oh, it's just kinematics. Okay, cool. Well, let's see. You are a ship operator, and a pirate ship currently rests next to you. Wow, what's up? Thanks for the raid, Cuber.
Good job.
How's Fortnite, dog? Yes, you're good, Sib. Yes, go study. Clicker questions, lectures, homework. Homework. All good things. Okay. In this two-dimensional problem, you are a ship operator and a pirate ship currently rests next to you. A dense fog suddenly emerges such that you are unable to locate the pirate ship. However, you know the pirate ship will only travel at a constant velocity v in a particular direction. If you start your engine T0 after the pirate ship begins moving and travel at speed u, what is the optimal path you should take to guarantee catching the pirate in a minimum amount of time? Okay. What's up, 1K? You got cooked in 1v1s? Uh-oh. Is this just like move around in a circle? Is the answer just like go around in a circle? Bro, what? Is this a JEE question again? What is this, dude? Competitive. Yeah, it's what's up, Mousy? Mousel, what's up, dude? Mousy. What's up, Zhongju? Good to see you, Jaden. Yeah, so I think I get the question, right? Which is that this goes off in like some random ass direction, right? So we don't really know, right? It is kind of like a random walk. And they're saying like, what path should I take? Yeah, I agree. You should just like keep doing this shit. Because you have no clue which direction it went, right? You know, if you try to only go this way, you're gonna miss it over here. But the key thing is that your like the expansion, like the propagation outwards needs to be at least faster than V. Otherwise you'll never you'll never catch the pirate. But then you also want to man, I see how this is a mind fuck, because it's you want to spin around quick enough so that you can identify what direction it is, but you don't want to do that too much that you don't catch it. So I think you want to be spiraling as fast as you can without losing the pirate. And so there's something with T naught. Yeah. Spiral search pattern, yeah. What's the equation for that? I don't know. I assume it's like some ooh, what's that? It's gonna be like it's like some theta. Then it's gonna be like sine theta t plus cosine theta t, basically. Like you need the radius to be increasing as you're like going around. You could make a parametric, yeah. Office hours is at 5 tomorrow, Mistral. 5 o'clock. Well, it's dense fog, so you have to like run into it apparently. Yeah, you could do it in terms of r theta. Well, here's a good question. Oh, what's the minimum amount of time? That's rough. Let me think. Also, wait, how big are how big is the pirate ship? Yeah, exactly, right? Yeah. Don't you need to know the width of the pirate ship? Because you're basically asking like, where does this intersect with this? And that's gonna be really tricky for it to do it like exactly at some exact point in T. Yeah, send what you got. Yeah, I'm curious. You know the pirates are VT. Well, VT plus V naught, right? So, right? So R of the pirates is equal to VT plus V naught. Maybe it's interesting to know that you can instantaneously change your direction. Yeah. I mean, you can send what you got in the chat there. That's cool, Aleph. Just send it. So then R is equal to like UT. Or sorry, not plus v naught, plus t naught. Sorry, that's what I meant to say. When you reach their angle, yeah. But the thing is that you have to hit their angle at the certain time, at the right time, and you have to be the same R. Okay, wait 5 minutes. Okay, cool. All right, let's sort of ChatGPT. I'm just curious. I mean, this is just like ridiculous, this question, but it's fun. Yeah, but your first step is to move out VT naught in a straight line. In what direction? Yeah. Well, you have to. The minimum time is if you're moving in the same direction, right? But it's the you don't know which direction to go, mouse, right? Thanks, Amelia. I appreciate it. Oh, apparently, so this problem is like the lion and the man puzzle. Man, we're killing a lot of dolphins with this this question. The pirates are. I don't know. Oh no, dude, that's too good. That's a good joke there. I like that joke. That's a good one. The pirates are. Yeah, no, so I think, well, from the question here, Mazel, I think we assume they're point masses, right? They say, the ships can be approximated as point particles. So you assume they don't have any width. Correct. Correct, Horsey. Very correct, Horsey. Yeah. That's what we're basically saying. But then I'm just curious how you write out the spiral function to make sure that the radial propagation is at least is at least greater than, I guess, equal to V? Yeah, I agree with the rate of change for the radius vector. But then how fast angularly do you, I mean, of course I would love to travel at an angular speed of like infinity, right? Okay, here. We made ChatGPT think for a minute and 44 seconds. Place a polar coordinate system. You know the pirate will set sail some unknown ray. Phi equals theta, sure. You can sail at speed. U is greater than V. To guarantee, you must choose your heading so that your radial component matches the pirate's speed. Sure, R prime must equal V. R phi. No, we assume they're on top of us, Horsey. They're point particles. Okay, yeah, R phi dot. That tells you how much. Cool. Interesting. This is the answer. Here, I'll give you the link for it if you want to check and understand it. I don't know. It's a little bit above my brain at this point. I'm also like drained from doing that what was it? Electric field of an infinite charge. But yeah, pirate interception strategy. It's kind of cool. What time do we usually start streaming? It varies based on the day. So we have a calendar. Yeah, you're welcome, Alif. So here's the calendar. Here, I'll send it to you in the chat. Which chat do I gotta send it to you? This one. There you go. So that is so our next stream is tomorrow, starting at 5 o'clock Pacific. But also Zach's gonna be doing math help at noon. And then Penn Center's got like some machine learning stuff on Friday, so that's the most up-to-date calendar for when we help out with questions. Let me see. I got Shantrix and Reki still got a question as well. Yeah, you're welcome, dude. Shantrix, you around? Is your bro around? This was Shantrix's question. Shantrix, let me know if you're here. I need to fix this kudu thing. Night, Aleph. Yes. Okay, let me see. I want to make sure. I think here, electric field of an infinite line of charge. I believe this is wrong. I think we still got that. We still got lambda z. Yeah, that was okay. And then from negative infinity to infinity, this expression here is not okay. Because what we had, where was it? Where did I do it? There it is. Okay. Yeah. It should have been just over. Yeah. They got too many things going on. Need a Z on the bottom. Yeah. Cause we had a Z squared there, which canceled out with the Z there. And I think we found this also in here. Yeah. 1 over 4 pi epsilon naught x. Too many things. Sorry, where is it? Ugh. This is it. Yes, exactly, Femvox. Yeah, I was doing it today. That's what all this was. Sorry. So that should just be x over z squared. I think that's what I had as well. Ooh, I had x over z. Interesting. I think they're wrong as well here now. What? I don't think this simplifies to this. Whoa, is fucking physics LibreText wrong? Let's check this. I don't think this is correct. That's nuts. Because if x is infinity, you have like infinity over the square root infinity. Yeah, sure, there's a factor of 2. What's up, Shantrix? Yeah. 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 Wow, they're wrong. No. Bro, what? LibreText is wrong, dude? No way. That's nuts. This is a very well-respected website, by the way. And their derivation is wrong. Yeah. I wonder if I can, like, send them an email. Be like, yo, dog. This is like Wikipedia being wrong on, like, a very basic thing. What's up, Sim? You got Master Chief coming out. Okay, sorry. Let me fix this. Sorry. This is... Have you ever seen that meme where it says, like, someone on the internet is wrong? I need to fix this. This is my duty as a physics person. I have to fix this. It was here. This statement here needs to have just a single z. Dude, there's so much wrong with this equation. Okay, no lambda z on the top. No z squared on the top. No, just a single z. Yeah, none of this. Stop. Can you edit LibreText? I don't know if you can. This is what it should be. It should be lambda x over z. Yeah, this is correct now. Can I go in here and edit this? Oh, I can make some annotations. I wonder how that works, though. Can you just, like, highlight this and be like, hey, yo, this is wrong, dog? I have to, like, log in or sign up. I'll do it at some point. Okay, here, let me Shantrix. Let me help out your question. Math. We love math. Okay, we're going to do some math. Okay. It is only true for a particle on the z-axis. I was doing this question, which is like it's not a particle, but it's you have an infinite line of charge and you're figuring out the electric field here due to like all these little individual like DQs. It's just, yeah, the calculus is kind of hellish, the integrals, And I found like 2 different sources that fucked up the integral. Yeah. Jeff says, finally math. Here we go. Okay. 12 points are equally spaced around the entire circumference of a circle. In how many ways can 3 of these points be chosen so that the triangle they form has at least 2 sides of equal length? Oh, that's cool. Look, Jeff, it's your favorite, circles. Okay, so we have this. 12 spots. So, how's that gonna work? I need 6 on each one, so I need 30 degrees, right? Is that what I need? So what? Kind of like this. Spheres, cough, cough. He's like, I'm a spheres man, dude. Don't associate me with. I want to get this like perfectly right. I want this to look like perfectly balanced. That's like... Okay, that's good. Fine. Okay, so we got a 30. We got a 60 somewhere. And then we gotta have another 30. And then another 60. Right? So that's having, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Good job.
Okay, cool. And then you're going to pick 3 points so that the triangle has at least 2 sides of equal length. Okay. So, in order for there to be 2 sides of equal length, I mean, I could do this, right? I could do this, this, and this. That's going to have 2 sides of equal length, right? So let's think like what the condition for that is. And then I could just like oscillate that, right? Then I could do this, this, and this. And then this, this, and this. And then I could do this, this, and this. So how many different ways can I do that? I guess until this comes back into this, right? So what's up, KCO Prime? It's combinatorics, yeah, right? Woohoo! Okay. So I can do that. Yeah, the problem is like the double counting, right? I don't want to double count. Let me just draw a couple so I can just kind of like make this make sense to me. I'm a very visual person. I like my visuals. And then I'm going to count all the different colors I have. Which I think I'm going to run out of colors eventually. How many more colors? Oh, we got black. We haven't used black yet. Oh, I guess, yeah, we're gonna triple up, aren't we? Rizzler, what's going on, dude? Oh, now Recky's here. Oh, I was looking for you, Recky. Yeah, I think you're right. I think we have 12. Right, because then there's just one more, which is this. Right, you take the leftmost point and you just rotate it all the way around. I agree. I'm just making sure that I don't like double make a triangle somehow. Okay, cool. So we got 12 from that. I should have copied this before I started like drawing fucking astrology signs on it. Oh no, is there a way I can just like delete? Sorry, let me just delete. I just want to delete all the colors. Watch out for the 60-60 triangles. They can overcount. Yeah, right. Okay, so we agreed we can get... And here, let me make this like color a little thicker. Let me make it like super thick. Okay. So this we can have 12 combinations. The other way to do this, and here, let me copy this one down a couple times so I don't have to like keep doing it. So that was like, if we had it like from here to here. Can you do it from here? No, because that won't match. You could do it from here to here though. Right? And I think this is the 60-60-60 we talked about, right? Okay. So in this case, you're right. In order to not double count, I can only go 1, 2, 3, 4. There's only 4 of these. Right? Yeah. And I'll just show some of the other ones. That's cool that this is one too, though, right? Or did I do that right? Wait. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. Oh, sorry, that's over here. I messed up. My bad. This is how this works. There we go. Thank you. I did screw up. I was looking at it, I was like, wait, fuck, that doesn't work. Okay, there you go. That's 4. Right? Yeah, because I could have, like, this. It's actually really pretty. Didn't know you were getting an arts and crafts stream today, did you? Okay. What's another way we can do this? The fuck is calling me right now? Nope. Not answering that. A 180, 90, 90? Like this? I think he's saying like this. Yeah, right? Okay. But I think that only has 6 combinations. Right? No. No, it has a full 12. This has 12 combinations as well. Okay, cool. Any other cool ways we can make some triangle-y circles? So we already did here to here, here to here with here. Can we make them even wider? No, I think this is the widest, right? Yeah, we've already done that. Because then otherwise, yeah, now we're just double counting these. I don't think you can use the middle point. No. Okay. Yeah, but I think they're distinguishable. Okay, so I think this is 30. Shantrix, does this answer 30? Reki says yeah. Reki just saying yeah, okay, yeah, okay. Oh, sorry, 28. Yeah, sorry, I don't know why I said 30, sorry. Yeah, 12 plus 12 plus 4 is not 30. It's plus 6. 28.
Good job.
Okay, nice. Oh, Reki, are you is Shantrix talking for you from your account? Is that how this is working? Nice. Okay, that's cool. Respect the factorial. Okay. Delta 8 Zeta. What did you submit to me, dog? What is this? Windows update? Oh no. Okay, well, tell Reki I will do his question next. Let me just see what this one is real quick. Someone asked this. Let mu be the measure on PR with mu 0, 1 is less than infinity and 2 such that mu equals 0? What is this? Who submitted this to my stream? I love when people submit like some pretty ridiculous. Does this make? Is this English? Here, I'm gonna tell ChatGPT to solve it. Solve this, please. Oh, I wasted a whole. There you go. We just killed a whole dolphin with that. That looks like a screenshot of a YouTube video I know. Here's a classic Vitali set argument showing that any translation invariant countably additive measure on all subsets R, which is finite on 0 to 1, must be identically 0. Bro, what? Isn't Vitali that guy that went to jail for like doing too many pranks and shit? Oh man. Yeah, this is I don't know what this is. Y'all start scaring me with some of the math stuff. I'm like, what the fuck is Vitali set? That's true. Oh man. What is that? Is that discrete? It's measure theory. Ooh, that's cool. Yeah, I don't know measure theory. I never took a class. Pretty cool though. Pretty cool that ChatGPT can understand like what's going on. Okay. Divide the polynomial 3x to the fourth minus 4x third minus 6x squared plus 17x minus 8 by x plus 1 using long division. This is like much better. I can do this. I like this stuff. This stuff's always fun. Notice how they said they don't want us to use synthetic. I actually do. Synthetic actually would work pretty nicely for this, but it's okay. Okay. 3x to the fourth minus 4x to the third minus 6x squared plus 17x minus 8. Always make sure that you have all the different powers going down of x. If you were missing one of these, you got to put like a 0, like a 0x. But we have all of them. And we're dividing this by x plus 1. So whenever you have long division, you just check for like how many times does this thing go into this thing. You look at like the highest thing here and the highest thing here. And that case is 3x to the third. And then you multiply this all through. So then that becomes 3x to the fourth plus 3x to the third. Subtract, these go away. And you're given negative 7x to the third. Key thing, don't add these. It's always minus. So make sure this is always minus this minus this. So minus 4 minus 3 is minus 7. You don't like polynomial division? I think it's fine, dude. It's not that bad. So then this goes in negative 7x squared times. So you want like this times this to get you to the power. And then you want whatever the coefficient is in front of here times this to get you the coefficient here. So now I have negative 7x to the third. And then we say minus 7x squared. Subtract these. This is 0. Another thing, if you don't get 0 here, you did the wrong thing. You should get 0 for the first one. Okay, but and then also, sorry, there was also a minus 6x squared here. So then this is minus 6 minus minus 7, so that's plus 7. So that's just going to be x squared. What's up, Recky? Wouldn't it be like minus 3x to the fourth? Yes, it is. So it's, well, this was 3x to the third, so that became positive. But then you subtract the whole thing. That's the key part here. Okay. Okay. Yeah. You're subtracting the whole thing from this. You want me to add the brackets? I'll add the brackets. That's cool, man. Let's do it. They don't usually do that in class, but I'll add them for you. That's a good idea. Okay. And then how many times does x go to x squared? Well, that's just a single x. So I'm going to say plus 1x. So I'm going to have x squared plus x. And then here, let's draw some arrows down. And then this is going to be here. And let's make things nice. Let's make things like super nice. Oh wait, this doesn't come down. I don't know who Number File is on YouTube. I'll check them out after this though. Are they cool? They do like high-end math stuff? Okay, so then this gets subtracted, right? And that's going to give us 16x. And then so the last part is just 16. So this is going to be plus 16. So that's going to be 16x plus 16. And then you had this part coming down. Minus 8. Minus. So minus 8 minus 16 is going to be minus 24. Okay, so then this is your remainder. So your final answer is going to be all this on top. And then we're going to say minus 24 over x plus 1. Yeah. Cool. And that's all equal, right? Yeah. To they do grab math content for a decade now. They invite professors and discuss. Oh, cool. Number 5. Let me go figure him out. Let me go see where he is. Oh, pretty big. 4.7 million. He's got like... Let's see, how long have they been around? Since 2011. Wow, look at that. 700 million views. That's really cool. What's up, Ski? Good to see you, bro. I do use YouTube as well. Oh, good to see you. He's back. Let's see. Yeah, my channel. I don't think says that many. Yeah, we only have well, we did recently pass 1 million. I thought that was pretty cool. Yeah, we were in 2021. We have 1 million. So, just how many more million? Just 700 million to go. 701 million to go. It's work time, so sad. Uh-oh. Anyways, nice job, Reki. You get a point. I hope that made sense. This one we did. There's some cool stuff with like finding zeros and stuff. Isn't there? There's some cool properties of doing long division, I remember. Like, yeah. So for instance, if p of x over x minus a is equal to this, then I think if you multiply both sides by x minus a, you get p of x is equal to q of x, x minus a plus r. I think this is called the remainder theorem. And so what that says is, oh, okay, I think I remember this. So p of a is equal to r. Yeah. So this is actually really cool. So if you plugged in, like, for instance, a here for x, this becomes a minus a, so this goes away. And so the value of the function at a is equal to the remainder. So that tells me that the value of this at x equals -1 is equal to 24. And let's see if that's right, actually. So 3 times -1 to the 4th minus 4 times -1 to the 3rd minus 6 times -1 squared plus 17 times -1 minus 8. Let's just see what we get here. So this is 3 minus, so that's going to be plus 4 minus 6 minus 17 minus 8. So that's 7. 7 minus 6 is 1. 1 minus 17 is -16. -16 minus 8, -24. Whoa. It's the same thing as the remainder. That's super cool. The remainder theorem. I think it's cool. Yeah, Newton's method, right? That's another one you can do. Yeah, there's a lot of cool stuff with it. So wait, Shantrick said the answer is not 28. Uh-oh.
Disqualified.
What is the answer then? I feel like we made lots of pretty things here. Which ones are we missing? I'm gonna keep drawing like pretty shapes. $52 is the answer? Excuse me? Okay, but how'd they get 52? Because I can go on forever. Happy thoughts, you know? These are happy thoughts. You can draw 1 left, 2 further. Okay, 1 sec. One left, 2 further. Oh. Wait, how? Oh, you're talking about this? Oh, damn. Yeah, you could have done this. Oh, sneaky. Okay, I forgot about these. Yes. Yeah, exactly. Okay, I see. I was having fun drawing all these. I forgot. Yeah, you could also do these. And then you could rotate these around like 12 times. I was being obtuse. God damn it. God damn it, Jeff. What question was this? Alright, here we go. Yeah. $52. Okay. Cool. Alright. I don't think we have any more questions. I gotta go teach someone else. So, let's end the stream. Thank you everyone for coming to Actual Education Office Hours today. Had a lot of fun working through questions with you guys. Appreciate everyone's participation, all the fun stuff. Our next stream will be tomorrow. That's going to be at 5 o'clock Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by. Have fun. Make sure you check the announcements for summer camp. We're going to start doing challenges this weekend. So if you want to win some cool prizes, learn some math, compete in chess tournaments, or Fortnite tournaments, Roblox tournaments, all sorts of fun stuff. We're going to give out a Nintendo Switch 2 as well. Come on by. It's in our Discord. If you don't know our Discord, the link is like right there. Right? It's right there. Right there. Okay. Let's go raid somebody. Is Zach still streaming? Also, why do I have to why do I have to log into Twitch? Bro, what? Excuse me? Ugh. I am logged in. Okay, 1 second. Needs my authenticator app. Twitch. 8, 5, 9, 5. All right, let's go raid somebody. Who are we gonna go raid? Who am I following? Yes, dude. Hell yeah. Let's go see. Zach's been streaming for 10 hours. Fuck yeah, dude. Let's go say hi to him. Okay, cool. All right, go wish Zach a very happy stream anniversary. We'll see you tomorrow. Peace.